This video is a briefing on fasteners. Do you know what a fastener is and what is it used for? Let me bring you deeper into the topic of fastener. Fastener is actually a hardware device that mechanically joins or fixes two or more objects. They are mostly used as a reason that they are quick, reliable, and easy to use. It is also easily disassembled. Have you seen what a fastener looks like? Here are some examples of fasteners. From what you are seeing, you can see examples of bolts and nuts. There are many more examples of fasteners which are screws, rivets, pins, and many more. Selection of consideration on the type of fastener to be used plays an important role. Strength, corrosion protection, method of installation, type of loading and thickness of material plays an important role also. There are also other types of joining methods which can be said permanent joining methods. There would be crimping, welding, soldering, taping, gluing, cementing, and many more. Okay students, this slide shows an example of a fastener. Watch carefully and challenge yourself and see if you know what type of fastener this is and how it is used. The next slide will show you a video on how this rivet, which is a blind rivet, is used.
Rivets are strong, lightweight fasteners. Here's how a pop rivet works. A rivet has a shank and a mandrel. The rivet is inserted in a hole drilled through two materials. A rivet gun pulls on the top of the mandrel, expanding the shank. As the shank expands, pulling on the mandrel clamps the two materials tightly together. The force from the gun then snaps off the mandrel head at a pre-made breakpoint. It's called a pop rivet because of the sound the head makes when it snaps off.
Here is an example of a solid rivet. Bucking bar and solid rivet gun would be the most important equipments to be used. Watch this video to know how it is used.
The rivet should slide into the hole with just a little bit of friction, if anything. Now the back side, in this particular application, what I'm going to be doing is holding the bucking bar using this large surface. So, here we go, the first one. No deformation, no smiling on that side. Right there's about 1.5 times diameter is what our bucked end would look like.
This is the countersunk rivet. Countersunk rivet have consideration on its size with specific measurement when being used. So how do we choose the right countersunk rivet? Here is a picture. Which one do you think is the correct countersunk rivet? This? This? In conclusion, the rivet in the rightmost position will be chosen because it has good fatigue strength and its depth is greater than 2/3 of its sheet thickness or more than 60% of the overall material thickness. This is a challenge for you guys. Why is countersunk rivet used on aircraft instead of blind or solid rivet?
Everything that would induce turbulence with its attendant drag must be reduced to a minimum. The use of a rivet, whose head is flush with the surface being riveted, eliminates the drag of the ordinary rivet head and thus aids in accomplishing our higher speeds.